Oh. Okay, we seem to be live. Now, for the next type of graph, so we're still looking at the different types of graphs. I'm going to start looking at the circle. Now, the circle is kind of weird. I've got it on the screen. In the top left, you'll see that there's a unit circle, which just means I've got a radius 1. And yeah, I guess that's kind of what we start with. Now, it's got a strange equation, so it's kind of like all the equations previously you would have seen that it's y equals something. This is not the case. There's a few reasons for that. But if you look at it, it's essentially Pythagoras' theorem, and that's how you, I guess, come up with the equation of a circle in the first place. So I'm just going to, I guess, draw a circle. I'll draw a perfect circle. That doesn't even look like it's dead center. Now it does. So you think of it like this. I've got my circle. I'll call it, I don't really want to call it a unit circle. That's y, that's x. Now, at any point on the graph, so any point on the graph that's not that, let's go with, I'm sure the circle. Let's go with that. Let's call that the point, and it's got an xy coordinate. So just like any xy coordinate, and it has a radius of r, and that's 0. The equation of this circle is x squared plus y squared equals r squared. And I think that's kind of easier to see, and I guess I can illustrate that here. I suppose that's y, so like distance in the y direction, and x, which is the distance in the x direction. That's essentially just Pythagoras. X squared plus y squared is r squared. X squared plus y squared is r squared. That's how the equation of the circle pops up. So literally just from Pythagoras. And I guess I could do an example. I know I have a green pen. Let's not have a green pen. So I've got one. I want to, what is the equation of a circle ball with center 0, 0 and diameter 14. Okay, easy. I know it's x squared plus y squared equals r squared. X squared plus y squared equals, now r squared, my radius here is 7. So I'll write 7 squared, and you don't have to leave it like that, you can leave it as 49, and that's fine. Okay, that's pretty basic, and yes, we do go a little bit further than that. If you were in 5.2, that's actually as far as you go. Let's think about this. Let me draw another circle. I hope that people know what this music is, and I hope it's loud enough to see it. Thank you. See music. Or do you? Okay. Make this a little bit smaller. Now, really easy to just be like, okay, well, here's a circle, but what have we done before? Well, we move things left, right, up, and down. So when you move things left and right, what happens? Well, remember that you replace, so if it was x squared, you replace the x with x minus c, and that moves it to the right. Well, it's the same deal here. I just grab this and I make it x minus. Now, I'm not going to use c just simply because I want to be able to use, because you know how when you move things left, right, up, and down, I've been using c for both of those. So we're actually going to use h and k. So I'm going to replace this with h, and what that's going to do is I'm going to move it to the right h. So if I wanted to move this thing to the right, and this value in here is h, then I'm going to have the equation x minus h squared plus y squared equals r squared. And you can see that in the top left corner of your screen, that h value, if I start increasing that, it's going to move it to the right, and you'll see the equation changes, x minus something, in that case the h, and it's moving. So let me leave that maybe at 1, so it's moved over to the right 1. Now, before, if I wanted to move things up and down, what I was doing was I was adding a plus c on the end of things. But what I was trying to say at the end of one of the videos was, and this is why I said it, at the end of the one of the videos I was like, okay, well this is y equals x squared. If I wanted to move that up, I write plus c. Now, what that's actually doing is when I have something right next to the x, so in other words, like this, it moves it in the x direction. Now, this isn't right next to anything, but I can make it so it's right next to something. So I can rewrite this as y minus c equals x squared. All I did was grab this and move it over. So now that I've got that, I've got this minus c right next to the y, and I could draw a set of brackets there. Now that's actually moving this in the positive y direction, just like this is moving it in the positive x direction. So really, all I need to do is replace this y with a y minus something, and that's going to move it up and down. So I just want to show you that it may not seem like we're being very consistent. It's like, okay, well, I have to put a plus sign on the outside here. Why am I putting a minus c inside here? That's not consistent. Well, actually, it is. We're just doing a little bit differently, I guess. So if I wanted to move this thing left and right, up and down, I'm going to have to go like this. I have to move him. I'll have to go that minus, now use h and k, and that's that. So then if I move this up, this value here is k. So now my center is the point h, k. So all I've got is two equations for a circle, one where it's not moved, so centered on the origin, and one where it is moved, centered on the point hk. Another thing, if you just made these zeros, so that would mean the center is 0, 0, then you wouldn't even have to write these, and I'd be left with this anyway. So I just kind of want to show you that all these equations don't come out of nowhere. They actually have a reason as to why they exist. And I'm going to go a little bit step further and prove why this one actually does exist. So if you think of, I'm going to have to move this hk, oh, damn it, I'm going to have to rub this out. So that there is the point hk. If I then do what I did up here and draw a right angled triangle, so if I go like this, that's the terrible right angled triangle, you get the idea. Now, this here, so I'm pointing at this, I need that and that. I still know what this is r. Let me get this in green. That's r. This value here is, okay, well, I don't know what that is, but it's my x coordinate. It's going to be x. So I'm looking for this. I have to find this minus this, which is x minus h. So this here is x minus h. Same argument for the other one. If this was the y value and this is k, then this distance is going to be y minus k. So that there is y minus k. If I were to use Pythagoras on that, it would be x. So this squared plus this squared equals this squared. That's actually exactly what my equation is. Well, shall I write that? So maybe proof. R squared equals, I don't really know if I need to write this, because the thing is pretty, like I've only got one line of working. Pythagoras. Okay, so that's kind of it for the circle. Now, in the textbook, they go a little bit further, and I'm actually going to break this lesson in half because there's something in there that I kind of want to talk about in a little bit more depth. So at the moment, all I'm really going to do is kind of leave it here. I'm going to just do 4 examples. 1, 2, 3, 4. We'll just draw some circles, but other than that, I don't want to go much further. I've got x minus 2 squared. I'm just going to draw each of these. Let me move that over. I really hope you can hear that. That's easily treasured trove code. Okay, so what we're going to do is we're going to start each of these by identifying what the center is and what the radius is. And once you've done that, that's pretty much it. So here, the center is going to be, now it's pretty much the opposite. Like here, this is the point h, k, and I've got a minus h and a minus k. So here I've got a minus 2 and a minus 5. So my center is kind of like the opposite. So, sorry, delete please, 2, 5, and my radius is the square root of 9, which is 3. Or I could just rewrite this as 3 squared, and that's my radius. So then if I want to draw that, and you don't need to be accurate at all, really, I just need a center of 2, 5, so 2, 5, we'll call that there, and a radius of 3. Okay, so that might be my circle. Just label the point, so that's the point 2, 5, and my radius is 3. That would be enough. Now notice that there are y intercepts, and it is something that you could find, and I'm going to make the challenge, well, the challenge for this. Challenge. I want you to find the x and y intercepts. Even though my graphs should probably have them. Let's call that question 5. Okay, so same thing. I'm going to find the center. So the center is going to be for this one minus 3. Minus 3, minus 1. And the radius, I think quite clearly is 4. Or I could just write the square root of 16, which is 4. Or I could rewrite this as 4 squared, and then I can see that. I'll probably draw that. 1, 4, minus 3, minus 1 is about there. Radius of 4, so I guess it crosses that axis. So then I'll just write, that's the point, minus 3, minus 1, and the radius is 4. That's honestly enough. Y, X, arrows, 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 arrows. That should probably actually be touching the circle. Oh my god, okay, screw it. Okay, it's ones that like this are a little bit confusing, but they're not too bad. The center, you can see the x coordinate is just 0, and the y coordinate is 6. Now the radius is the square root of 1, which is just 1. So then if I draw a circle, I've got 0, x up 6, and radius 1. It's a bit like that. So that's telling me that the radius is 1, and that's the point 0, 6. That's the center, minus 1, 4. So it's literally just these, but the opposite, so minus, plus. The radius in this case, I want you to leave it like this. Don't simplify it, just leave it as root 40. So I can rewrite this as root 40 squared. Leave it as root 40, because otherwise it just looks kind of weird. Actually, the circle probably looks weirder, to be honest. But minus 1 plus 4. The radius of root 40, which I don't even know what's root 40, just in terms of scale. My calculator came up as 2 root 10. Okay, 6. It's around about 6. So I call the radius root 40, and that's the point, minus 1, 4. Okay, but again, you can see from the pictures that they have x minus x. I mean, this is only up 4, so really this circle should go down here, right? So should be drawing that a little bit bigger. And then you can kind of tell how many intercepts I've got. See, I've got quite a few. And I guess where your intercepts are kind of depend on what the circle is going to look like. So if I draw my circle like up here, and then I find out that it has x and y intercepts, then it doesn't really make any sense, does it? So just be a little bit careful. I know I'm being kind of terrible here, but you can be a little bit more rigorous, I suppose. So that's it for the circle. We're actually going to do another lesson on the circle tomorrow, but for the moment, all I want you to be able to do is graph a circle that's not centered on the origin and potentially find its x and y intercepts. That's all I want you to be able to do today. So when you look at questions that I've set, there are real specific ones. Yeah. And I guess if you just look at the circle up here, I start moving the k value, it goes up and down. If I start moving the r value, it gets bigger and smaller. So I guess you can believe me in 3 different ways. 1 from just telling you, 2 from my Pythagoras proof, and 3 from my digital tool on the top left. Okay, that's everything I think you need to know about the circle for now.